name's Corey. I work with the North Richland Hills Library and MakerSpot, and today I'm going to show you how to use our 3D printers. They are Polyprinter 229s. So whenever you come to our library to use one of our 3D printers, first you're just going to have to have your library card, and any Texas resident can get a library card. Once you've got your printer checked out with the reference desk, they're going to give you a key, and each piece of equipment in here has its own key, and it even has a specific piece of equipment written on there too to kind of help you out. Once you get here, you're just going to unlock your piece of equipment. You'll find this attached to the electric cord of each piece of equipment. Mine's already unlocked just for today's demonstration, but just to show you, you're just going to turn the key 90 degrees, slide the lock off, and plug your equipment in. So first thing you're going to want to do when you get here, once you've got your equipment unlocked, you're going to want to turn on your 3D printer. Like I said, this is already turned on, but if you're just getting here for the first time, you're going to find the on-off switch located in the back right panel of the 3D printer. It's a toggle switch. You're just going to flip it up to turn it on. Once we open the lid of our 3D printer, you're going to see two toggle switches in the front. These are just light switches. They don't have to be on to actually operate the 3D printer. They're just going to help you see your object as it's printing and to make sure that there's no debris or unnecessary material in the 3D printer. So to get started, we'll talk a little bit about what 3D printing is for those who might be unfamiliar. 3D printing, in its most basic sense, is just a type of manufacturing. We have fused deposition model 3D printers, which means it's just a fancy way of saying that they're going to take material and melt it out layer by layer to create your object. Think about it how the pyramids would have been built, or anything like that kind of structure, where it would have started at one layer, moved up to the second, third, fourth, fifth, and so on until it was finished up at the top. Now, we're going to go into a bit of the hardware on 3D printing. So where most of the 3D printing magic is going to happen, and I'll show you this a little bit closer later on, is this part right here called the extruder. This is going to be responsible for taking our material, which is called filament. It's a big roll of it. This is just one long continuous piece of plastic. What this extruder is going to do is take that material, grab it, and push it through something that's going to heat the material up and spit it out layer by layer. So to load your filament, there's a little apparatus back here. It's just going to receive your filament. You're just going to lay it right on top of there, and it should spin freely. There's a small holder in the back here. You're just going to take the end of your filament and make sure you're really holding onto this well. This filament is very springy. It's going to want to unravel as soon as you let go of it. So you're going to put the end up through this little holder back there. That's just going to keep it from moving around too much while it's printing. Back here, you'll see this yellow circle. There's a bearing inside of there. This has a magnet behind it. If you just gently pull on this yellow circle, you'll see it's going to separate, and you should see this little switch back here. This is called our filament switch. This is actually a super important part of threading the filament. This lets the computer know that there's filament loaded in the 3D printer and that it's ready to print. So what we do is we're going to put our filament up over that yellow circle. There's a little lip there to catch it. And like I said, it's magnetic. We're just going to gently push it. You should hear a pretty satisfying click. And that's going to push that switch up. If you skip this step, you're just going to get a bunch of error messages in the software program saying warning, check filament, because it can't detect that there's filament loaded. It's a pretty common mistake for people just getting started. Next, we're going to take the end of our filament and load it into what's called our extruder. This is going to be responsible for actually melting and spitting out the plastic layer by layer. So what we're going to do is we're going to put our thumb down on this yellow lever. It does have a pretty strong spring on the other side of it, so you're going to have to put a bit of force behind it. And you're going to just put your filament down into the hole on top of it. I don't know if you can see it from there. There's a hole right on top of that extruder lever, and it's going to take about that much plastic, about 2 to 3 inches of plastic. Just going to put it in there. Once you feel a stop, don't force it any further. So again, that extruder gear is going to grab that filament, start to turn, and it's going to continuously turn to push our plastic past the hot end where it's going to get melted, and keep turning until it's pushed out through our nozzle down at the bottom there. Now, as our 3D printer is actually printing, we have 3 axes of motion that are going to work together to lay plastic down at the right place at the right time. We have our x-axis of motion, which is going to be our extruder sliding left and right on these metal bars. We have our y-axis of motion, which is responsible for driving the component called the bed. This is also going to be heated to about 110 degrees Celsius, and you're going to see your plastic build up on the bed layer by layer on here, and the bed's going to move in the y direction, the backwards and forwards direction. And then we have our third axis of motion, which is going to be our z direction, which is going to lift this entire extruder unit up and down. So now that you know how to load the filament and you know a little bit about the hardware on the 3D printer, we're going to dive into the two software programs necessary to get a file successfully printed. So once you have your 3D file, whether you designed it yourself or you downloaded it from a website like Thingiverse or Yegi, we're going to need to run that through a software program called a slicing software. Like we said before, 3D printing is additive. And what that slicing software is going to do is it's going to break down your 3D model, whatever that model is, into layers that the 3D printer can understand as layer 1, 2, 3, and 4. We're also going to put settings in that software program like how fast our model needs to print and the density we would like it printed at too. Once we've sliced our file, what we're going to do is then load that file into what's called a printer control software. That software program is just responsible for controlling our 3D printer. That's going to be responsible for things like heating the printer up, making sure the motors are adjusted correctly, and it's also going to let us monitor our printing process as it's finishing. So let's go ahead and take a look at those software programs.
All right, everyone, the first software program we're going to talk about today is what's called a slicing software. So the slicing software we're going to be using today is called KISS Slicer 64. So I'm going to go ahead and open it. I'm going to ignore this message for a little bit. We'll talk about what that is later. So since 3D printing is an additive type of manufacturing, and fused deposition model printers lay that material out layer by layer, you need a software program that can take your full 3D model, whether you created it in AutoCAD or SketchUp or Blender, and cut it into layers that a 3D printer can understand and print out. So the first thing you're going to do is you're going to want to open your 3D model. Now the file type we need is what's called a .stl file. I created mine using AutoCAD Fusion 360. If you use Tinkercad or Blender, it should be able to create those too. Most 3D design programs are going to be able to create the file we need. If not, there's a lot of converters you can use to create an STL file. So we're going to go ahead and hit open in the top right corner. And I have my file saved in a files to be printed folder. And there it is. So the first thing you're going to see is sometimes this little error message will pop up. It's telling you that it detects a minor error or a possible error with your model. Again, we'll talk about that in a little bit. This model is going to print just fine though. Whenever you open your model, it'll automatically import to scale in the center of the print bed. Again, that bed is going to be the area that the nozzle is going to lay that plastic down on top of layer by layer. And our KISS slicer here is already scaled for our 3D printers. So your object will import to scale. Again, our poly printers can do 229 millimeters in every direction. That's about 9 inches in the X, Y, and Z direction. Whenever you upload your model, you're going to get this little menu in the top right corner. It's going to give you some functions that are related to how the object's going to sit on the bed, like how many we're going to print, the orientation it's going to print on the bed, and the scale of the model. So that's what this count button is going to be how many you can print. And a cool feature about KISS Slicer, if you hover your mouse over anything, it'll tell you what that function does. So if you ever forget, hover your mouse over it, and it'll tell you what it does. So the first thing you're going to see is how many to print. We're going to arrow up, and it's just going to increase how many little keychains we're going to print. Today we're just going to do one, but this is really useful. Instead of you having to upload the same model time after time, you can just print multiples on the bed at the same time. Underneath of that, you're going to see something that says height with a number in it. This is how tall your object is in the Z direction on the bed. So my object's 6.24, that is in millimeters, so it's about 1/4 of an inch thick. If you imported your object and you realize it's too small or too big, you can adjust it as you need here. So say if I wanted my keychain to be 9 millimeters thick, it would scale it up. And it'll also tell you what percentage it's increased. So it says it's now 144% of the original size. If you design in inches, that is absolutely fine, but just be aware that when your file imports into KISS Slicer, at least our KISS Slicer, it's going to automatically think it's in millimeters. So my object earlier was 6.25. That's about 1/4 of an inch. So if I designed it in inches, it would import thinking it was 1/4 of an inch thick, or 1/4 of a millimeter thick, sorry. My object is still there, it's just really, really tiny. If you import an object and it looks like this, where you just see the X and Y indicators, usually means it was probably designed in inches. To fix that, just right-click the secondary image in the top right corner and press inch to millimeters, and it will scale your object to millimeters for you, or convert it to millimeters. Sorry guys, I'm tongue-tied today. So again, use this if you need to scale your object up or down. Now, that's the only aesthetic change this program can do. If I realize that I didn't have something attached correctly, or since it's a little library keychain, if I realize I had misspelled library, I can't fix that in this program. That would have to be done back in the 3D design software. All this can really do is scale the model up or down. If it turns out that your model is not fitting on the bed properly, say if it's just slightly larger than 9 inches, or if you have a lot of files you're trying to print at the same time, that's what this feature down here is for. This is a rotate button. It'll rotate your object along that z-axis. That's not really going to do too much for us today. Our object is tiny and it's perfectly centered on the bed. That's what we would want at this point. But if for whatever reason you needed to rotate it, that's what this feature does down here. You can also type in your angle too if you want. You don't have to use those arrows. So once you have your object sitting on the bed how you want, you've got how many you want to print, it's the right size, and you've rotated it if needed, you're going to come down here to the Style tab. What this tab does is it's meant to kind of choose a quality setting of your object. The first thing you're going to see is a drop-down menu. And we've got 5 different options. Some of the newer versions of KitSlicers will have more, but it's the same idea. You're going to choose the style or quality setting for your object as needed for its application. So the first thing you're going to see is we've got 3 mechanical settings. That is exactly what they sound like. If your object is going to be a tool or under any sort of stress or tension, you would definitely want to default to choose one of these settings. They are optimized for things that need to be a bit more durable, maybe need to be a bit more dense, things like that. The art setting, exactly what it sounds like. This is going to print your object using settings that are more optimized for things that need to be precise or aesthetically pleasing. And then the base setting, we'll talk about that in a second. So first thing with the mechanical settings, you do not have to type in your own settings on this software. It will automatically import some presets for you, and if you just want to use those, that's absolutely fine. Some of our most experienced 3D printers do just that. They don't type in their own settings if they don't need to. These are already optimized to work with each other, but I'll kind of walk you through what each one means. Skin thickness is how thick the outer wall of your object is going to be. Right now it's set to 3/4 millimeter. That's pretty common for us. That's usually what we use for most of our objects. You can make it lower or higher if needed. Come talk to me if you have any questions about how to optimize that setting for your object. Things that are a little precise or maybe need to be a bit more delicate may need a thinner skin thickness. Things that are a little more durable may need to go upwards of 1 millimeter. Number of loops, this is just how many times our 3D printer is going to outline your objects before it starts filling in the middle. Don't worry about that setting too much. There's not usually many things we would need to change that for. Extrusion width, this is just how thick each layer is going to be as far as the actual width of the layer, not so much the height of it. This is just defaulted to be our nozzle thickness. One thing that kind of sets each setting apart, and I do want to go over this because there may be situations that you would need to change this, is layer thickness. The reason that this is set to be our mechanical setting is it has a thicker layer than the other settings. Thicker layers mean that your object's going to take a little bit less time to print and will be a bit more durable, but you are going to lose some of that precision. But this definitely makes our object print faster than, say, with that precise art setting. One thing I will definitely advise you guys change if needed is infill percentage. This is going to be the density of your object. Most things we 3D print here are not done at 100% solid. That would use a lot of material and it takes a lot of time. So what we're going to do, is if you need to increase the density of your object, you're going to arrow this to the left. 100% infill means our object is going to be 100% solid. That's pretty overkill and would be really, really dense. What we see most of our patrons print at is 10 to 33% solid. Oops, sorry guys. The interesting thing is most of these mechanical settings are actually the exact same setting, they just default to different infills. So mechanical stock will default to 20%, high density will default to 50% infill, meaning it's going to be 50% solid, and low density is going to be 10%. Otherwise, all the other settings are the exact same. Most of our patrons are going to default to use that low density setting, but please choose what you see fit for your object. The art setting, like we talked about earlier, is going to have thinner layers, so that layer thickness goes down to 0.125 millimeters. Before it was 0.25, so we go from 1/4 millimeter to 1/8. Really tiny layers are going to be able to pack in that detail, but it's going to take a whole lot longer too. Everything else in our version of KitSlicer is going to stay the same. In some newer versions, you may see that your skin thickness goes down a bit. That's just going to help to get more precision on finer detail. But again, please change your infill if you need. You are not bound to stay at that default that setting chooses. If you need more infill, please do so. Just be aware that you can go too little on the infill. If you either do too little or none at all, which would be this setting here, base, your object could collapse in on itself as it's building those layers. If there's no internal structure or internal density to kind of keep it together, it can kind of collapse on itself like a souffle, and we've seen that happen. So I would say try to stay in that 10 to 33% range unless your object specifically needs different. Now the last setting we're going to talk about in here is vase. We do not use this too often. The only thing that kind of makes this different is it defaults to have no infill. This is meant for objects that are supposed to be entirely hollow or just a shell of the object. It would be exactly what you think it is if you were to take the object off the print bed. If you squeeze it too hard, it would just collapse because it would just be a tiny thin plastic shell. Super cool for just doing prototypes to see how things are going to look or what the size are going to be if you don't want to use too much plastic. I've also seen people use this setting for really, really delicate prints that need to be extra lightweight. Not super practical for anything that's going to be mechanical or under any stress, but just a cool setting to play around with if needed. The next thing we're going to talk about is support material. So support material is necessary for an object to print properly, especially if that object has unsupported layers. Again, in 3D printing, since we do layer by layer manufacturing, for the setting I chose earlier, which I forgot to do, sorry, we're going to do a mechanical setting for this book. This is a little keychain. It needs to be somewhat strong, but we don't need it to be overkill on the infill, so we're going to set this down to 12%. This is going to be a pretty general, good setting for things like this. So since we are doing additive manufacturing, when we lay down each layer, or when the printer lays down each layer, if there's anything that's unsupported, say if the nozzle's up here at this level where the book cover is, we need some type of material to hold that layer up as the printer is laying down that hot plastic. So that's what the support material is for. What the printer will do, or what the software is going to do, I should say, is it's going to scan your object and see where there's any unsupported layers at. So we have an unsupported layer right here. So our software program, if we choose to have support materials, is going to build this little kind of pillar support as the object is printing to hold that book cover up. In the newer versions of KissSlicer, you have a little bit more options to play with, but it's all the same general idea. For most people getting started 3D printing, I would say choose this normal setting. It's better to have the support material and not need it than need it and not have it. Because again, if you needed support material for your object to print properly, again, if there's anything unsupported, just kind of hanging out there in space with nothing underneath of it, it's going to need that plastic pillar support to hold it up as it's forming. I would always advise choosing the normal setting, and I would leave the defaults where they're at. If it turns out your object needs a little bit more help, come find me. I'd be happy to talk to you about it. That's what the sliding bar is. You can increase the density of the support material, but sometimes it'll make it a little bit difficult to remove later on if your support material is really, really dense. So the lowest setting, which is coarse, which is what it should default to, is going to be just fine. And this sliding bar down here is the support angle. This is going to determine where the support material is going to go. If we hover over it, it says any surface of the model more than X degrees off of the vertical will get support. Meaning, so from our Z-axis, if that's straight up and down, anything more than 46 degrees away from that, which would be about right here, if there's anything on your model hanging off the Z-axis greater than 46 degrees with nothing underneath of it, it means it's going to need some type of support material, or at least if we have this activated, it'll put those little support beams underneath. And support material can be cleaned off really easily with either pliers or nail files, X-Acto knives, things like that. You can increase this angle, so if we increase this angle, it'll lessen the area that will actually have support. So say if we put the support angle at 55 degrees, it'll move from 46 to 55. So it'll have less of an area that it's going to apply that support material. But as a general rule, I would leave it at that 46 degrees. It's a little bit overkill, but again, it's better to have it and not need it. If you are someone who has specifically designed your model to not need support material, or if you do not want to have to mess with it as far as removing it, and you know your object doesn't need it, but the software program may try to put it on there, use this no support setting. Again, I would only advise this for people that are printing models that they know do not need support material, and they don't want the software program to put it on there. If you choose the no support setting, the program will just go on by without putting support material where it needs to. So again, good if you know it's going to do it in an object that doesn't need it, and you have experience printing it before, but again, as a rule of thumb, I would choose that normal setting. The last thing we're going to talk about right now is material. We typically use ABS here, so if you go one tab over to the material tab, you'll see a drop-down menu, and we have EABS or PLA. Pay attention to what material you're using. Again, if you're using our material, most likely these general ABS settings are going to be just fine. If you bring your own material, make sure that our settings are right for your material. So if you choose ABS and you brought your own from home, make sure our temperature settings are gonna work with your filament. Not all filaments are gonna melt at the same temperature, so make sure that our main temperature, which is what it's usually gonna be printing at for most of the print job, is agreeable to what your filament has. And it'll tell you on either the side of the box, or it'll usually be a sticker on the side of your filament roll. We use 1.75 millimeter ABS plastic for most things. If you are someone who is bringing PLA, you are going to have to change it to the PLA setting. And again, just like with ABS, make sure that these temperatures agree with what your filament says on the box or the sticker on the side. Same thing, it'll be the same diameter filament as well. Everything else on here is just going to be presets to make sure that the material and the file is going to the right printer. Totally ignore these other things. Like I said, these are just presets for us. Once your file is done, you're going to hit slice in the top right corner and ignore these error messages. This is going to create G-code for your object. G-code stands for general code, and it's actually what our 3D printer needs to have the set of instructions to properly print your file. So we're going to take G-code from KissSlicer and move it to our next program. So where we're going to upload our G-code to is the second type of software called a printer control software. Our printer control software is called Polypronter. So here's the icon that you're going to be looking for on your desktop. Like I said, I already got mine open, so it's going to be down here. And here's what it looks like. This has a lot less options than KissSlicer does, and we use it for pretty much just heating up our 3D printer, uploading our G-code, and making sure the printer is doing what it should be during the printing process. Like the name says, printer control software, it's responsible for directly controlling the 3D printer on our end. So we're going to first, when you open up the software, normally you would hit this connect button. I'm actually not connected to a 3D printer. It's a little bit noisy in the area we keep our 3D printers in, but normally what we do is once you open the computer associated with your 3D printer in the maker spot, you're going to press this connect button in the top right corner. I'll let you guys see what it looks like if it has an error. If you press connect and your printer's not turned on, or if you were on the wrong port, you will get this error message. So if you get this, make sure your 3D printer's turned on. That should be your first step. And also make sure it's on the right port. Ours should always default to COM4. If it doesn't, just make sure you select it. If we had other stuff hooked up to us, that would show the other ports. So make sure it's on COM4 and that your 3D printer's turned on, otherwise you'll get this error message like we did today. But again, we're not hooked up, just for the sake of the video as an example. Once you are ready and you've got your 3D printer connected and you don't get the error message like I do, you're going to go ahead and select your G-code. So I have a lot of G-code here because I use this laptop for 3D printing quite a bit. We were doing the book keychain from earlier, so I'm going to hit select and hit open. And here we go. So don't freak out because you're not going to get that really cool 3D view we got earlier in KissSlicer. What this is going to be is like a layer by layer management view. And the super cool thing is, so this area right here represents our 3D bed. Again, that part of the printer that's going to let the nozzle lay plastic up onto it layer by layer. If we click this, just left click with our mouse, we can actually run through those layers. And this, I would advise most of you guys do this just because it's cool, at least I think it is. And it's also a good way to double check that your model's going to print how you expect it to. So if we drag this little lever up, it'll tell us in the bottom corner what layer we're on. The reason we don't see anything yet is the printer's actually going to do 2 test dots to make sure that the nozzle's not too close or too far away, and that's what we're seeing right here. So at layer 3, you'll notice there's nothing because it's still doing those test dots in those layers. We would call that finding 0, I guess. And then so what we're doing is once we'll notice it goes back to 0, and then here's where we see our object at layer 9. That's what the first layer is going to look like. And if we run through this, this will just be a layer by layer compilation of everything that's going to make our object. And this is based on all those settings we chose in KissSlicer. So you'll see all this kind of squiggly area. That's our infill setting we chose. If we had chosen 100% infill, we wouldn't see any empty space here. It would just be totally solid. And you'll notice we back down to those early layers. Let's see, we chose one of those mechanical settings, which means each layer is 0.25 millimeters, and you're going to see that represented here. So at layer 0, there's nothing. 0.25, we've got our first layer. 0.5, we've got our second. 0.75, our third. And then we start to build into those infill layers. That's based on the actual skin thickness. If we had put that to 0.5 millimeter or 1 millimeter, it would be different. So as soon as we get to 0.75 millimeters and right beyond that, we see that we start to get our infill percentage. You'll also notice all these kind of weird squiggly lines. That's our support material holding up that cover layer that's going to need that support. If we had chosen no support, we could possibly get away with it for this object, but again, it's better to have the support material and not need it than need it and not have it. You'll see all these squiggly lines. That's just representative of where the support layer material is going to be, and we can rip that off later. We keep running through, we get back to the skin of our object or the final layers. You're going to notice there's a couple of these before we start getting to the lettering. And then that's where it says NRH Library and our logo, and then we finish up at the top. Super cool thing just to kind of run through and make sure your object looks good. Also, just like before, in KissSlicer, it is to scale, so if it looks huge here, and it shouldn't be, check your scale on the slicing software. Same thing if it's microscopic here and it shouldn't be, probably means we need to reset the scale. Once you load your G-code, you're going to get all this information about your file. Please pay attention to this. This is important, especially this last line of information. This is going to be kind of our chat box. This is going to tell us how long our file is going to take to print. So it's about 5.5 minutes. That's pretty close. This software can be kind of off on its estimate. It is in the ballpark, but take it with a grain of salt. If it says an hour, it's probably going to be pretty close, but we've seen it go either way, where it says an hour and it could take 40 minutes. Sometimes it says an hour and it could take an hour and 20 minutes. So give it about plus or minus 20%. I don't love that we have to do that, but just keep in mind, so pay attention to this and just make sure you have enough time available in either your reservation spot or make sure that your object's not going to run over to when we're closing, because again, we don't do any overnight print jobs, so your object is going to need to be finished once the maker spot is closing. You'll also see that it tells you how tall and wide your object is. This is just a good way to double check yourself that all your dimensions look right. I put it to be 6.25 millimeters high. That's perfect. The other cool thing is once this is actually printing, you will get error messages if they happen. So say if you run out of filament, it will tell you here like, hey, warning, check filament, because it means that filament switch doesn't detect anything underneath of it. So keep an eye on this as your object is printing, just because it's going to let you know everything about your model that you would need to know or about the printer status as it's printing. The other thing too is now we are not hooked up to a 3D printer, which is why these are grayed out, but these are our motor controls. You'll see X, Y, and Z. Those are associated with their X, Y, and Z axis. And anytime you see a home button, that means it's going to send that motor to its home position. You guys really do not have to mess with these. I would never move the motors by hand, especially if the printer is turned on. It's not really good practice. So if you need to say move the nozzle up, that's what the Z plus is. It moves the nozzle up in that Z direction by the number of in millimeters it says here. So if we hit Z plus by 10, it'll move our nozzle up by 10 millimeters. Definitely use these if needed, but you probably won't need to use these too often. Same thing if we see a Y minus, it means it's going to bring the bed in, which is responsible for our Y direction, or the motor that's responsible for moving the bed in the Y direction. And same thing with X. It's going to move the motor in the X direction that it needs to go, which would really be where the hot end goes left and right, and it can move it left or right depending on. And this middle button is a center button for all motors. The home will send it to the home position, which is always at the front left of the bed. It'll bring all motors to the front left section and down on the bed. This is what we really use to make sure that all the motors are aligned properly and to do nozzle height adjustments. So again, don't worry about those too much, but I did want to let you guys know what they do. You're not going to hurt anything if you accidentally click these, and in fact, it won't let you overwrite it if it's in a place that the printer can't move it there. So don't worry about hurting it. The other thing that you will actually, it's just a good practice thing, is to use these flush extruder buttons, extrude or flush extruder, because there's always going to be a little bit of residual plastic left in the nozzle and hot end area or extruder area on the printer. You don't know what color filament the person was using before you, and there will always be a bit of that residual color. So if this is a final product or something that needs to look good, make sure you hit these flush extruder buttons once your printer is heated up before you start printing. Again, if you don't do that, not the end of the world. You just may notice the first layer of your object or part of the first layer of your object may have a different color associated with it. Say if I was printing in black and then afterwards you came to use the 3D printer when I left and you were using blue, you would see a little bit of black filament on that first layer if you didn't hit this flush extruder button. Once you hit this, it'll extrude all the plastic, and once it stops, we're going to have you clean the nozzle with the brass wire brush to move the extra plastic away before you get started printing. Again, you want to make sure your printer is entirely clear of debris before you actually get started. And then the last thing we'll talk about is actually, I'm kind of working backwards here, sorry guys, is the first thing you should really do when you get here to the 3D printer. For just the video's sake, we started with KissSlicer, but if it was me coming to use the 3D printer, I would open my printer control software first, and then go ahead and set the printer temperatures. You don't have to type in your own temperatures. We already have it set for you for ABS. Once you open the software, you are just going to press these set and set buttons, and what you'll see is that these are thermometers down at the bottom. They will tell you what temperature they're at, and once you're ready to get started printing. So again, I'm not hooked up to a 3D printer. Sorry guys, I wish I was just for the sake of the video, but it's a little too noisy to have it hooked up and try to do the recording. So if you're using ABS, it'll already be defaulted for you. You'll just press set. You'll see these thermometers are going to become active, and they'll let you know how hot the printer is, and they will stop when needed. You don't have to worry about that. And our bed is automatically defaulted to you. So you'll hit set for the extruder, set for the bed, and it'll heat it up for you. If you are using PLA, don't worry if this is set to ABS temperatures right off the bat. As long as you change the material setting in the slicing software, once that G-code, again, which is the set of instructions we get from that program, the G-code will automatically override what temperature settings you have in here. So even if you set it at ABS first, if you upload your G-code into this program and your material settings are set at PLA, it'll automatically change it for you once you get started printing. So once you've got your file loaded, everything's heated up and ready to go, the next thing you're going to do is come up into this area and hit print. Now again, if we were set up to a 3D printer, what you would see is that this would then clear the screen, and then it would do a layer by layer view in real time as your object was printing.
So once you've got your model actually printing, we do have a few rules we want you to abide by while you're here. One thing is always leave the lid and side panels closed while 3D printing, even if you're using PLA. It's just a good practice to make sure you're not breathing in the burning material, and it's just safer just in case young ones want to put their hands in there. We do have children who come into the maker spot quite a bit, and we want to make sure it's a safe environment for them also. We do know that some models can take a long time to 3D print. Our model today is only going to take about 5 minutes. We have had some models that can take upwards of 3 or 4 hours. We do want you to stay near or with the 3D printer while it's printing. We understand that you maybe want to use a different piece of equipment in the maker spot, or you may want to sit down on our couch and read a book. That is absolutely fine. We just want you to be able to return quickly to check on the printer to make sure that, one, the filament didn't get tangled, that there wasn't any issue with the file, or anything like that. Because even though the model might look correct in the computer, you may see it printing and realizing that that is not what it's supposed to look like, or that the size isn't correct, and we want you to be able to be here and be attentive to that just in case something needs to change. Also, like we said before, please never put your hands inside the 3D printer that's moving. There is a pause button in the software. We want you to hit that pause button, say if the filament is tangled or you need to remove something from the 3D printer to fix something with the model. Please always hit pause ahead of time too. The other thing we want you to be conscientious of is making sure that your model is going to be finished 3D printing by the time the maker spot closes. We do not do any overnight print jobs here at the library or the maker spot. So we ask once we are closed that your model is done printing and that your area is cleaned up. So once your file is done printing, you're going to wait till the printer control software says that the bed has cooled down to at least 60 degrees Celsius. Until that point, just to let the file cool down properly, or I should say the model cool down properly, leave the lid and side panels closed. So since we're at about 60 degrees, we're going to go ahead and remove our model from the print bed. We're going to use that spatula. And you're just going to pry it underneath of your model. If you need, you can touch the top of your model to make sure, because sometimes it'll fly off in an odd direction if it's really stuck on there. And we're just going to use our spatula to kind of scrape it off of the bed. Here it is. Now, one thing you want to think about, if you are done 3D printing for the day, go ahead and remove your filament. You're going to do the exact opposite of how you put the filament in there. You're going to press down on this lever and pull the filament out and take the roll out. And you're going to want to do that while the printer is still hot. At least the hot end is above 180 degrees Celsius. That's just going to allow that plastic to slide right past that extruder gear. If your filament has cooled down too much and you notice any resistance as you're trying to take it out, go ahead and heat your 3D printer back up. You never want to pull this plastic out of the extruder while it's cold because it'll break off under that extruder gear. We're going to have to kind of take it apart to get that plastic out of there. Not the end of the world, just heat it back up if it's too cold. Once you're done with everything, you're going to go ahead, close the lid on your 3D printer, shut down your software programs, turn your computer off, and you're going to come over here and turn the 3D printer off. Once you're done with everything, as a courtesy to the next person who may be 3D printing, please clean up your area, any plastic debris, any snacks or food you may have. Go ahead and put everything that you checked out from the reference department back in that bag. You're going to lock up your 3D printer and bring the key back to them too. And what they're going to do is they're going to go ahead and take the 3D printer off of your library record. Again, they're just going to check it in like they would check in a library book. Before any of our library patrons can come and use our MakerSpot equipment, there's always a brief test to show that you're confident and comfortable on the equipment. We will post a link to those test questions in the video description below. We really look forward to having you come use our equipment, and please feel free to call us or email us if you ever have any questions about our equipment or our library services in general. Thank you so much, and we really look forward to seeing you.